In this lesson, we are going to discuss how chemists measure particles. Now, the unit they use to measure particles is called moles. Why moles? Because it comes from the Greek mole, meaning pile or heap. So it just means a number of particles. I like to liken it to how farmers measure their eggs. And this is something very familiar to us. Farmers measure their eggs in dozen, right? So if you go out and buy 2 dozen eggs, that's just you're getting 24 eggs. Now, a mole just means 6.02 times 10 to the 23rd. Similar to how a dozen means 1.2 times 10 to the 1. In other words, a dozen is just 12 of something. So I did that on purpose just so you realize it's just a number. Now, the reason why chemists do that is because particles and atoms and ions, they're very, very tiny. So, why do we use moles? Now, conveniently, the mass of any 1 mole of any element is the atomic mass in grams. So what that does is that relates the number of particles to something that we can easily measure by weighing. So, for example, if I know I need 1 mole of hydrogen, and you might want to pause it and take a look at a periodic table for a second. But if you get your periodic table out, you see that the atomic mass of hydrogen is 1.00 grams. So that means that 1 mole of hydrogen has a mass of 1.0 grams of hydrogen. 1 mole of carbon, you look on the periodic table and it actually says 12.0111, but in our class, we're just going to round to the tenths. Now, there's a reason why we're going to round to the tenths always, even if you put that 0 there, because it'll help you remember which one's the atomic mass. The atomic mass is always the one in the periodic table with a decimal. Don't be confused with the atomic number, or else you'll make some grave mistakes. So another example would be 1 mole of zinc. You look up on the periodic table, you find that zinc is 65.4 grams per mole. So make sure you do round properly. And this is called the molar mass. Simply stated, it's the mass of 1 mole. Now, what if we have less than 1 mole, or we need more than 1 mole? Well, that's like saying to a chicken farmer, can he have half of a dozen or 2 dozen? Well, yeah, it's easy. So, if we have 0.5 moles of carbon, that's how many particles we need. We can go measure out 6 grams of it. We know from up here that 1 mole is 12 grams, so half of that, half of a mole, is going to be 6 grams. Similar, if I need 2 moles of carbon, that's 24 grams. And we're going to be doing some more of this as we go on, but it's an important skill to know. We could also compare number of atoms or mass to find out which is more. Similar to how if we're comparing $12 and 5,000 cents. We have to remember to compare like quantities. Now, it doesn't really matter which one we compare to find out which one is more money. We can either say $12, that's 1,200 cents, or I can say 5,000 cents is $50. And we can easily see if we compare like quantities, you compare $12 to $50, obviously $50 is more, or you can compare 5,000 cents to 1,200 cents, and it's the same. Now, let's go down here a bit and figure out which one has more atoms. 6 grams of hydrogen, well, that's we know that 1 mole of hydrogen is 1 gram, so 6 moles of hydrogen is 6 grams. So this is 6 moles of particles, moles of hydrogen particles. Whereas 6 grams of carbon, we talked about up here, we just talked about that. That's 0.5 moles of particles. So we can easily see that 6 grams of hydrogen has many more particles than 6 grams of carbon. Or we can figure out which one has more mass. Well, comparing 1 mole of hydrogen to 1 mole of carbon, well, we can look up the molar mass. We know 1 mole of hydrogen is 1.0 grams. And we know 1 mole of carbon is 12.0 grams. So we can easily see that 12 grams is more than 1 gram. So that would be the more mass. So you'd weigh out more. But actually it's the same number of particles because you have the same number of moles. Interestingly enough. So we're going to be using these skills pretty much for the rest of the year. So it's important to understand that because this is what chemists use to measure particles, and it's not going to stop anytime soon. So we'll be doing more of this in class, guys, so I'll see you later.